This is the video presentation for our paper, Learning Dense Visual Correspondence for Category-Level Garment Manipulation. In our daily life, there exist many categories of garments, with diverse shapes and deformations. Manipulating diverse garments is an essential ability of future home assistant robots. Current garment manipulation algorithms usually propose task-specific algorithms for different tasks, such as unfolding, dressing, and folding. The goal of our paper is to propose a kind of unified representation that can facilitate different garment manipulation tasks over different kinds of garments. Specifically, we propose to use dense visual correspondence for different garment manipulation tasks, such as fling, fold, and hang, using one or a few shot human demonstrations. The dense visual correspondence indicates the point-level topological and functional correspondence among garments in the category level. We propose to use skeletons, a graph of key points and edges to represent the structural information shared among garments in the category level. While previous works only propose skeletons in rigid objects, we first predict garment skeletons in flat states and project the skeletons to different garment deformations. We train dense visual correspondence for garments using the cross-deformation correspondence collected by self-play and cross-object correspondence collected by the skeleton points. We use PointNet++ to extract per-point features and InfoNCE loss to contrastively train point-level features. Further, we use a coarse-to-fine refinement module to eliminate inaccurate predictions. Therefore, the model is able to learn point-level visual correspondence, aware of garment structures and deformations. With one demonstration garment and the demonstration manipulation policies for different tasks, for novel unseen garments, we can use the learned dense correspondence to select the manipulation points, and thus generate the manipulation policies to accomplish different tasks. We present manipulation results, including fling top, fling dress, hang dress, fold top, and fold trousers, by showing the observation, dense visual correspondence, selected manipulation points, and corresponding manipulation policies. For quantitative evaluation, our method outperforms baselines and ablations in various tasks. Moreover, our proposed dense correspondence is a kind of unified representation for diverse downstream tasks, while baseline methods mostly could only tackle a specific task. Our real-world setup includes 2 Franka-Panda robot arms and a Kinect camera. We first conduct the alignment on the real-world point cloud, and that in simulation, and then use correspondence to select manipulation points, and thus guide manipulation. We show the observations, correspondence, and selected manipulation points guided for real-world manipulation tasks, including fling top, fold top, and hang dress. Thank you for watching. For more detailed information, please refer to our main paper.